You're all very welcome to this joint Engineers Ireland Irish Computer Society webinar entitled Preparing for Cyber Attacks and Building Cyber Resilience Strategies and Everyday AI. We have a super lineup of speakers this morning. Dr Diarmuid Ó'Briain, a Fellow of Engineers Ireland and lecturer in IT Carlow, will talk to us about the importance of internet exchange points in the COVID-19 world. Bob Semple, Fellow of the Irish Computer Society, will talk to us about cyber resilience, and Dr Glen Collins, Chartered Engineer, will talk to us about everyday AI and what we should know about it. Following the presentations, we will have a panel discussion, and I do hope that you will all feel free to join in through the Q&A function. I would now like to introduce you to our very special guests today, Mary Cleary, newly appointed Secretary General of the Irish Computer Society, and Maurice Buckley, President of Engineers Ireland, and I'm very happy to hand you now over to both Mary and Maurice.
Good morning, everyone. I'm delighted to be here. My name is Mary Cleary. I'm the Secretary General of the ICS, the new kid on the block, I guess, really, as I'm only recently appointed to that role, but I have been with the Irish Computer Society for quite a long time. So I'm really delighted to be here with Maurice for the first of what I hope will turn out to be a series of joint events between the ICS and Engineers Ireland. It's not the first one ever. We have had many collaborations in the past, but first for some time. So it's really, I think, only right and proper to bring to the same stage the engineering professionals of Ireland and the IT professionals of Ireland. Now, I've worked with Maurice before, and I really look forward to working with him on future collaborations between our two professional bodies. And really, we have many common causes, not least of which is growing the pipeline of talented engineers and IT professionals to fill the ever-widening gap between supply and demand. Both of our professional bodies support our members right throughout their career journeys, helping them to master best practice and to implement the new transformative technologies that are facing us in new and exciting ways every day. So we have a clear rationale for this cooperation, and I hope to be able to facilitate it on an ongoing basis. Thank you.
Good morning, everybody, and it is great to be here today and to be with Mary and the ICS members who are joining us. As Mary said, Engineers Ireland and the Irish Computer Society have a long history of working together. In the last number of years, it's probably fallen a little bit into abeyance, but I think both Mary and I and Caroline Spillane are very keen, and John Byrne, of course, very keen to rebuild that relationship and interchange. And today is a very good start. I'm very much looking forward to this event. Members of Engineers Ireland will know in my own presidency, in my presidential address about a month ago, I very much emphasized the importance of digitalization in everything we do as engineers, and our need to be innovative and our need to be very open and in a learning mode to see how we can use digital technology to innovate the services we offer. We reinforced that theme in the State of Ireland report for 2020, where we had digital as one of the 4 topics. So I think everybody's agreed on the objectives. The key is how do you get there, and that is so tricky. So I think dialogues like today spark the thinking and will lead to further engagement. So very much looking forward to it. So without further ado, I will hand over to the first speaker, Diarmuid Ó'Briain, and look forward to his address.
Thank you, Maurice. My name is Diarmuid Ó'Briain, and I'm going to talk this morning about internet exchange points and COVID-19. Just give me a moment till I share the presentation. Okay, so we're going to start our story in Sweden, and that was the origin of the original internet exchange point back in 1992. Pre-1992, there were 2 ISPs, or internet service providers, in Sweden, Telia and Tele2, and they realized that the traffic they were sharing between each other was actually traveling by a very long circuitous route to the United States and back again, which wasn't very optimal. And being Swedes, they had to fix that problem. So they approached Sunnet, which is the university network in Sweden, with a proposal that they would somehow connect the two internet service providers such that Telia could direct traffic to Tele2 via the Sunnet network, and Tele2 could direct traffic to Telia via the Sunnet network. And that's exactly what they did, and that reduced transit costs as they no longer had traffic traveling to the United States and back. There was an improved experience for customers because they now had a much shorter latency or a much shorter path between them and the service they were trying to access. So let's quickly have a look at the internet and the model of the internet. So the internet is modeled originally on a three-tiered model. At the top tier, there are a very small number of international internet service providers who peer settlement free with each other. That means they exchange traffic between each other settlement free. Now, why are they doing that? It doesn't seem to make any sense that they would do something for free, but they're mutually interdependent. Each one of them owns, if you like, a portion of the internet, and they all need to be able to access all routes on the internet. So they see each other as peers and will settlement-free transfer traffic between them. The second tier are national and regional ISPs. And these ISPs are receiving most of the routes they buy as transit from higher tier 1 ISPs, but they will also have some settlement-free traffic between tier 2s that are at the same level. And that's actually one of the things IXPs, or Internet Exchange Points, facilitate, but they can also do private peering between each other as well. And at the bottom of the pyramid, we have local ISPs. And these ISPs, they service the businesses and the homes, and they buy all of their transit from tier 1 or tier 2, typically tier 2 internet service providers. Though, in fact, tier 3 internet service providers are kind of a dying breed because of internet exchange points. So this model creates a problem. The problem is, if we take a consumer who's trying to access a service on a large enterprise, the consumer and the large enterprise may be very local. They may in fact even be in the same town. However, if they use different internet service providers, and those internet service providers use different international internet service providers, it is quite feasible that the traffic between the two will travel by a very long circuitous route around the internet. And that increases latency. Latency is the delay, the time it takes for the packet to get from the consumer's equipment to the service, and from the service back to the consumer. So this creates costs, and it also reduces the quality of the service that the consumer can have. So the Internet Exchange Point, it inserts itself at a local level, interconnecting to the various internet service providers in a locality. So for example, in Ireland, the Irish Internet Exchange Point links to all of the ISPs and also to local content providers. But it also acts as a very useful point for international content providers who are unhappy with the latency that exists on the internet to put caches of their product locally. So for example, Netflix have a content cache in the exchange in Ireland. So here is the result of putting an IXP in place. The consumer now contacts, or their packets pass to their local ISP, and that local ISP has a connection either directly with the large enterprise or via the internet service provider of the large enterprise via the Internet Exchange Point locally. So we have a much shorter path, and therefore we lower the latency, lower the cost, and the customer is much happier. They no longer see the little symbol, the delay symbol on their screen. They're able to get the services at real speed. So what exactly is in this Internet Exchange Point? So effectively, it's an Ethernet switch, and the Ethernet switch acts as a connection point for content delivery networks, the likes of RTE, Netflix, Google, and the internet service providers who carry that content to their customers, Air, Virgin, Tree, Ripplecom, Aptus, etc., the ISPs. So the ISPs and the content providers share the same switch. On that switch, there's a root server. And this is like a router, but it's not quite a router, but it's like a router, where each of the members that are connected to the switch, they peer with the root server, and the root server supplies them with access to the roots of all of the other members connected to the switch. So for one peering, they get all the roots of all of the other members. And to put that in perspective, in Ireland, that's 113 members on the exchange in Ireland. So that brings us to the Irish exchange, the Internet Neutral Exchange, as it's called, INEX. Similarly to Sweden, Ireland had a similar problem with tromboning or hairpinning by long circuitous routes. So in 1996, the internet service providers in Ireland realized that their traffic was hairpinning as far as the United States or to the Netherlands or to the UK, and that really they could do something better. And they decided to create an internet exchange point in Ireland. So in 1997, the IXP went operational, and today has spread out to 5 different data centers around Dublin. And there's also an internet exchange in Cork, though it's not connected to the Dublin Internet Exchange. So there's 2 internet exchanges, if you like, in Ireland. And there are many businesses who are members of both exchanges, and that gives them quite a lot of resilience. So if there's a problem in Dublin with if there was a problem in Dublin with traffic, they can peer still with the other members that are peered in Cork. So a lot of the big providers would actually peer in both places. So if we look at the internet exchange over its first 2 decades, we can see that at the beginning of this century, the traffic levels were very, very low. But they steadily grew to 130 gigabits per second peak in 2016. And I would just want you to remember that figure, 130 gigabits per second. So that was a lot of traffic growth over that period. You'll see that there was also a proportional drop in the cost of port fees. So port fees are the fees that the members pay to be a member, basically, and to be a member with a particular port size. So you can also see that in the earlier part of the century, we had 100 megabits per second, 1 gigabit per second. But as time moved on, the exchange added 10 gigabits per second, then it added 100 gigabits per second as demand increased. But you can also see that the price for port dropped in proportion to the rise in traffic levels. So what about COVID-19? It has turned our world upside down. So since March, everything has changed. You know, the way we're delivering this particular CPD has changed. You probably have had to come into Clyde Road or something, or go to a hotel for it before March. And maybe there's some good things to be learned from the experience of COVID-19, like the attendance that we're able to have at a conference when we deliver it in this format. But what effect has it had on exchange points? Well, one thing about this HSE poster is that it has asked us to work from home, and it has pushed the Irish workforce to work from home, which has changed the balance of traffic on the internet in Ireland, not just in Ireland, across the world. So if we look at the icons on this particular slide, we see video, chat, and education icons. Many of these would not have been familiar to most people. And I know a lot of people on this call are probably from IT or engineering backgrounds. So you certainly would feel familiar with some of them. But I doubt if you're familiar with all of them, whereas today you're probably familiar with all of them. Now, it's not all rosy in Ireland. Broadband across the country is not homogeneous. So we have consumer broadband services that were never designed for home working. Some services have up-down ratios of 10 to 1, 20 to 1. I have a 20 to 1 upload-download ratio myself here in Shannon in County Clare. Now I'm lucky enough in that my download speed, I have 1 gig, but still in all, 20 to 1 ratio is very, very high. Some services have download limits. So maybe there's 70 gigabytes of download limit that's applied. And if you have 2 children, maybe a teenager in education using the internet, and then there are 2 adults perhaps in the house that are working, very quickly you can see that download limit approaching before the end of the month. There's a large gap between the urban and rural broadband services as well. In urban situations, you can expect services like 500 megabits, a gigabit, but in rural situations, it may be as low as 10 megabits. So there are very, very large gaps between the level of broadband in urban and rural situations. So how did INEX deal with the COVID-19? Well, very, very well, in fact. So the staff in INEX, first of all, had some data already from the various storms we've had over the years. So those storms have forced workers to stay at home, and INEX have noticed changes in traffic patterns during those storms. And that data presented some indication of what was coming down the road back in January and February. They also were lucky that as members of EuroIX, this is the European Internet Exchange Organization, that countries like Italy, who were already in severe restrictions due to COVID-19 back in February, were able to give information about the kinds of traffic level increases that they were witnessing on their networks. So what they did was in February, they pre-installed many additional ports. So they had additional ports available. So as ISPs started to feel the pressure and were looking for more port speed or increased port numbers of ports, they were able to provide them. They made sure that all of the infrastructure was fully remote accessible by the management team or the engineering team, and that they were able to direct remote hands using the staff that were in the data centers to make any changes that were required physically, like adding those ports. But the ports were already made available. They added an additional 100 gigabits per second of bandwidth between Park West and City West, which are the two largest POPs, if you like, in the Internet Exchange in Dublin. That gave a core increase of 30%, which was significant to deal with any capacity rises that were expected. So what happened? March hit, and you can see there on the graph that there was a big change in the traffic levels in March. In 1 month, we saw a 35% increase in peak traffic, a 20% increase in average traffic, which are massive increases in such a very short time. So I asked you to remember a figure from a few slides back, what the traffic levels were in 2016, and there were 130 gigabits per second. So now we're looking at hitting 500 gigabits per second, which is a massive increase in such a short period of time. And on the 24th of March, when Taoiseach Leo Varadkar was giving his address to the nation, it increased to almost 500 gigabits per second, setting a new record at the time for traffic on the Internet Exchange. So in summary, COVID-19 has had a massive impact on the way our economy works. We've pushed people to work at home, and businesses are now surviving by employees working at home. I'm quite sure many of you are working at home more than you ever were before. And this has led to a massive increase in traffic at the Internet Exchange, 500 gigabits per second at the moment. And thankfully, the team that were in place in INEX were well prepared. They took in information from other ISPs or IXPs, sorry, around Europe. They looked at their traffic data from the storms, and they put in the additional capacity and prepared well for for the new type of storm that arrived in March, i.e. COVID-19. And they managed it very, very well. There was a seamless transition from the lower levels up to that 500 gigabits per second. So we've been very lucky in that way. So thanks very much for listening to me for the last few minutes, and I'm sure if you have questions, I suppose you hold them for the panel. Is that the correct process, Sinead?
Diarmuid, hi, John Byrne here. Yeah, absolutely. All questions for the panel discussion afterwards.
Okay, thank you very much.
Yeah. So I'd just like to introduce Bob Semple now to give his presentation. So Bob is a fellow of the Irish Computer Society, and Bob is going to talk about cyber resilience. Thanks, Bob.
Thank you very much, and I'll just bring up the slides here. There we go. So that should be up for everyone to see. Good morning, everybody. Delighted to have an opportunity to share with you the results of a cyber resilience survey, which we published just earlier this week. And the reasons for introducing this particular survey were threefold. The first was that we'd seen an enormous increase in cyber attacks of one sort or another. And the very increases that Diarmuid talked about a moment ago gave witness to the fact that during the initial period of COVID, there was a reported 6,000% increase in COVID-related cyber attacks, where the bad guys were basically capitalizing on COVID and trying to trick people into clicking on things that they shouldn't using COVID itself. The second factor was that, in my experience, and I spent a lot of time working with boards and looking at board effectiveness and looking at skills of board members, I was seeing a distinct discomfort among board members in being confident and capable in challenging management on cyber resilience issues. And it was a concern that if we don't have that sort of discussion around the board table, then there's an increased danger that organizations will be unduly vulnerable to these cyber attacks. And thirdly, it was driven by a desire to provide practical guidance and support. And so a group of fellows got together as a working group, and we decided the best way of trying to persuade people to look at this more carefully was to conduct a survey. So I'm going to talk mainly about the survey, but I'm also going to throw down a gauntlet or challenge especially to the engineers on the call this morning, if I may. Over the years, formerly as a partner in PwC, I was involved in interviews with hundreds and hundreds, probably thousands of candidates over the years. And I have to say, I always kept a special eye out for the engineers. First of all, because of the rigor of the methods that they learned, and secondly, for the discipline of thinking. And when I looked at the web to see what sort of material I could find on engineers and resilience, I found all sorts of things. And for many of you on this call, this may be old hat, if you like. But the difficulty I find is that when you get to senior levels of management and into the board, not everyone necessarily has the skills, the insight, or the appetite to tackle some of the resilience issues. In fact, this was demonstrated quite clearly in a survey of new board members in the US. Last year, in 2019, 65% of board members appointed to boards, these are publicly quoted companies, had a skill in cyber or IT or both. Whereas just last month, the Irish Times published a report which commented on the number of directors appointed to public companies in Ireland, and the corresponding figure, corresponding to 65%, was only 3%. And so with that absence of deep talent on cyber, it's not surprising that we see some of these myths in relation to cyber resilience. And in our report, we debunk each and every one of these with hard statistics and insights to try to get the attention of readers to say, actually, this is something we really have to take much more seriously. To the claim that there isn't that much cybercrime, if cybercrime was a separate country, it would be the 13th largest country in the world. This is management's job. Well, yes, it is at one level, but that's not without the oversight from the board, a point which I'll expand on a little later on. And on the point of our IT security is strong enough, there's a lovely quotation from one security expert who says there are only two types of organization in the world, those who have been hacked and those who don't yet know they've been hacked. So with that said, let me get into the results of the survey itself. I'm conscious that I have a relatively small time to share this stuff with you. So here's a profile of the types of organization that responded, and these are all board members of Irish organizations. Secondly, the size of the organization, and third, the sectors represented. And as you can see, we got a good spread in all three categories, slightly higher than average, I would say, in relation to charities, but otherwise a very good spread, and certainly also a good spread from very small organizations under 100 grand, many of whom will say, this is not for us, this is only for big organizations, absolutely untrue, and all the way through to the very, very large organizations over €1 billion turnover. And what did we examine, or what did we report on? Well, I've 4 categories. First of all, looking at the right people with the right skills at the right time. Secondly, to look at the core responsibilities of direction and oversight. And thirdly, to ask the question, what sort of formal assurance has been given in these areas? Now, I'm not going to give you chapter and verse in this. In particular, I'm not going to give you the glass half full here. I'm only going to give you the really worrying results. And hopefully that will stimulate some debate and discussion later on in our Q&A session. So first of all, to capability and confidence. And if we don't have the right board members with the right skills, then it's very difficult for them to direct and oversee, which is their core responsibility. And here's what the survey actually tells us. So first of all, 1 in 3 of board members who responded to the survey have had no training on cyber in the last year. And given that this is an area that's moving quite so quickly, that's a real cause for concern. The next 3 areas I take as a group, because this is the update process that keeps the board informed about what's happening out there in the intranet and among the bad guys that are trying to get in. And that shows that less than 2 in 5 are getting routinely briefed on these 3 key areas. First of all, understanding what are the latest threats emerging on the cyber landscape. And there are, in this category, some of you, I'm sure, are familiar with the advanced persistent threat actors. These are the guys, typically state-backed, who have enormous resources. In fact, in one report from a chief information security officer who spoke to us as part of our work, he told us that one of these advanced persistent threat actors has the capacity to send out over 1 million phishing emails every day. And if they throw out 1 million and they only get a handful of responses, that's fine, because that clicking on those handful of responses gives them access and gives them the backdoor into systems, into ransomware, data destruction, data disclosure, and a whole lot more besides. Intelligence gathering is something which is increasingly being used on a sector-by-sector basis, especially in the financial services space, but in other ones as well, especially on critical infrastructure, because financial services and critical infrastructure are often the special targets of the bad guys. And a really interesting one is we've become ever more dependent on more compact supply chains and more dependent upon customers and suppliers and the respective IT systems. About 1/3 of boards have not had any briefing on the exposures which arise from connecting to third parties in that way. And that can be a really big issue. Lastly, and this is a very worrying number, about 3/4 of board members said that they had never tested a board incident response plan. And therefore, and I know certainly from my experience before in doing work on disaster recovery and business continuity planning, that's potentially a very serious issue, because when you haven't rehearsed it, you just don't know how things are going to pan out in practice. Churchill said, plans are useless, but planning is essential. And certainly my experience anytime that I was involved in doing tabletop simulations of disasters or big disruptive events was that you learned an enormous amount from actually going through that simulation of a disaster and saying, oh gosh, we actually haven't informed somebody, or we don't have a press release ready, or whatever the case may be. So quite a few issues involved there. So this is the right people with the right skills. What about the actual business of the board member or the director? And the first area to look at is direction itself. So all of a board member's responsibilities can be summarized as direction and oversight. We picked on 2 topics to examine. So on the left-hand side, there's a diagram which some of you may recognize from the COSO Enterprise Risk Management Framework, the updated framework that was issued recently. And they talk there about risk appetite, and in particular talk about how do we reach this sweet spot. We don't want to be in a space where we're taking very little risk, we're completely risk averse, we batten down the hatches, and that may be a very safe place, but it actually means that we actually get nothing achieved, we get nothing done. Neither do we want to be on the other side where we're taking really crazy risks, we're betting the shop on perhaps recklessly on new initiatives or expansions or product development or whatever. What we're trying to do is to get into this sweet spot. And the way the sweet spot is typically defined is through a formal statement of risk appetite. So that was an area that we wanted to see. Did the risk appetite statement reflect the board's position on cyber resilience? The second area that we looked at was the role that people play in the organization, because the vast majority, in one report recently, 91% of cyber attacks were reported to come from the people factors. In other words, sending that tempting little email, the phishing or spear phishing email that invites you, pretty please, click on this link and you will get the delayed package from the DHL, or you will get the financial incentive, or you won a prize, or whatever the case may be. So we were interested to see how well board members were telling us that they had given direct counsel and advice to their own staff to say, guys, watch out for this, this is really important. And while there were some good news stories in there, we also found that 1 in 6 of organizations had no statement of risk appetite at all, let alone a statement of risk appetite that properly reflected the stance on cyber resilience. And if people don't have that statement of risk appetite, that means that there's an increased risk that people will be either on the left or right of this sweet spot, either wasting resources in relative terms by being too safe, or else recklessly endangering the organization because they don't realize that this zone of risk is actually out of the pale. We're not going there, that's dangerous. And in relation to the people side of things, 1 in 10 of board members said that they hadn't even communicated the board position to their staff. Now, the reason I get excited about that is because even for the 89% who had, experience shows that it is remarkably difficult to get people to follow the wretched policy that we set, which is, if you don't recognize the source, don't click on the link. Best practice actually suggests that if you can get the click rate down to less than 15%, you're probably doing well. And that's really alarming because, in fact, all it takes, of course, is 1 click for your system to be compromised. In the case, for example, of a large company in Cork a couple of years ago, that's exactly what happened. 1 click compromised the system. The bad guys, it turned out when the forensic examination was done, the bad guys actually hung around for 2 years, unnoticed, unidentified, and they were keeping a very close eye on the CEO and on the finance director. And in particular, they got to know both of them really, really well, to the point where, having checked on the movements of the CEO, they knew he was out of the country and difficult to raise. They then sent in the false email. This is the so-called CEO invoice fraud, and it sent it to the financial director, and it was crafted so perfectly and had all the references and all of the connections that it was indistinguishable from the real thing. Of course, the finance director went and transferred funds of $250,000, and that was the last they ever saw of that. So when the people factor is so important, it's very, very concerning that the board hasn't even communicated to 10% of their, or 10% of them haven't communicated to their staff, but even more so, it's such a big challenge in practice. Okay, so much for direction. What about oversight? And many board members would say, hold on a second, Bob. I'm a director here. I attend 6, 8, 10 meetings in the year. I'm not here every day. I can't actually do the stuff. That's management's job. And anyway, you'd say yourself as a governance expert that the job of the board is to direct, but the job of management is to actually run the organization. And that's absolutely correct in the sense that, and take a look here at the key elements of what management have to do. First of all, they have to identify what are the assets we're trying to protect, then identify the risks that might affect those assets. As a result, put in controls which either eliminate those risks or reduce them to acceptable levels in line with our statement of risk appetite. And then recognizing from the earlier quotation that every organization is going to be breached at some stage or other, do we have the capability to bounce back quickly? So let me give you the stats first, and then I'll come back to the director's responsibilities. Sorry. Here are the stats. So over half of the boards have never endorsed a listing of assets. When, to have the conversation, well, tell me, CEO and everyone else from the management team, what are we trying to protect here? Can you give us a listing of the assets? Contrast between intellectual property versus financial assets versus all the different types of assets that are there. 1 in 4 said they were not so confident or not at all confident that they'd identified all the risks affecting those assets. 56% said they were somewhat confident that they had appropriate controls in place. And surprisingly, then only 10% said they were dissatisfied about their capability. But if more than half don't know the assets, and 1 in 4 are not confident about the risks, and nearly half are only somewhat confident, I look at this with a somewhat skeptical eye. Now, back to the point about the board members' role in all of this. It's absolutely correct to say that it's not the board members' role to do this work. They've delegated that to management. But it absolutely is their job to see that what they've delegated has been done to their satisfaction. And that's an aspect that some board members don't necessarily pick up on, and it's a really important one in practice, because if they're not seen to do that, then they will be criticized for not discharging their fiduciary responsibilities. Particularly in companies' legislation, there is an obligation in law that they must act honestly and responsibly. And if you can't demonstrate that you know what's to be protected, the risks affecting them, the appropriate controls in place, and a good capability, there's a real danger that they're going to be exposed about not acting responsibly. So the last element of the 4 in the report that we looked at was the question of formal assurance. How do we get assurance to the board that the appropriate work has been done? And that can come either internally or externally. And what we found was that about 1 in 3 had never had any formal statement from management, where management said, board, I want you to know we have done all that work on assets, risk controls and capability. 1/3 have never had that assurance at all. And that's a real gap in the process. And in terms of using external independent testing, only 50% are getting the testing, 50% have never got it. And so if I can relate this to a situation myself, I was on a board a couple of years ago where I got the answers from the head of IT and I just wasn't comfortable with it. And he assured me everything was okay. And I decided in that trust but verify mode, I decided we were going to get an independent check. So as chair of the audit committee, I got onto the external audit partner and said to him, I want a special purpose test here, do the check and let's see what we find. And not only did he breach our defenses, he drove a coach in 4. It turned out there were all sorts of weaknesses. And the problem, of course, here is that it's not how good individual measures are. It only takes one weakness to absolutely penetrate everything and invalidate all the best controls. So, roller coaster rate, I appreciate, but the question now is, where do we go from here? What do we do as IT professionals and as engineers? Well, I'm recommending certainly to board members, and we have a little mini site which I'd encourage you to go to, which has 10 key questions and 10 suggested initiatives. I just have 3 key questions that I want to raise in this session this morning. The first is just to ask the question, what training should we get to be match fit as board members? So that involves understanding what do we know at the moment, who has the skills, who doesn't, what's a sensible, a proportionate way, not to get carried away with all of this stuff, but just to get ourselves to a position where, not that we become experts in all of this, but at least we know the questions to ask. Secondly, how do we get better assurance? And that means asking, well, what assurance are we getting already at the moment? What's management telling us? What are our risk management committees saying? What's internal audit doing? Are we getting external tests? List all those different sources of assurance and see, is that enough, yes or no? And then we can take decisions about what else to get. And then thirdly, a question I'm suggesting is that the board ask, how can we improve our ability to respond? Have we got an up-to-date board incident response plan? Can we do a tabletop simulation? Can we see how this works out? And I can assure you from the experience that I've had that it's only when you do that test that you discover all the weaknesses in that plan. So there's the URL for the little mini site. It's on the Irish Computer Society site under cyber resilience, and there's a whole lot there. I'd like to finish up just with a couple of comments specifically, and this is the challenge, if you like, for our engineers on the call. When I look at the engineering resources and the sort of disciplines and the deep down nitty-gritty stuff, there is a fantastic array of material there. I guarantee you, if I put this list up in front of the average board member, you would get completely glazed eyes. They just don't know about this stuff. And the challenge, therefore, is when you look at the vast array of material which engineers and IT professionals too have put together down in the trenches, how do we bring the benefits of some of these things to the attention of not just senior management, but particularly board members? Because board members, at the end of the day, are the ultimate ones responsible. They're the ones who decide on how resources are going to be allocated, and they are legally ultimately responsible. So my question, and I'd love to get some questions on this and get some discussion going, is how do we get a broader awareness? How do we get more discussion at board level of these issues? How do we bring what Engineers Ireland and the ICS has to the discussion so that we can identify the most important things and get on and do it? Happy to take any questions when we get to that slot. Thank you very much.
Bob, thank you very much. That was absolutely inspiring on one level and I think concerning at another for board members, but absolutely fantastic. I'd now like to call upon Dr. Glen Collins, Chartered Engineer, who's going to talk to us about everyday AI and what we need to know about that. Thanks, Glen.
Thank you, John. I'm going to be spending a little time here talking about AI, particularly for engineering. So let me share properly. All right, are everyone seeing the slides here appropriately?
Yes, yep.
There we go. All right, so here we go. My name is Glen Collins. I have a background in artificial intelligence. I'm a retired chartered engineer living here in Ireland, mostly retired. So here's what we're going to look at today. First, I'll look at AI in the everyday world and give you some details on social media uses of AI. A little bit about AI in Ireland today, and then the impact upon the engineering profession in particular. So, of course, AI is in the news. It's in television shows and movies and so forth. It's seen now a lot with all of these assistants, with Cortana, Alexa. I mean, Alexa's talked about in common conversation by many people today, because a lot of people have devices, especially mobile devices, that have assistants. Of course, their large companies have been investing in AI. A little bit more on that later on. There's also in the news the use of AI tools and big data to influence elections, including some recently contested and talked about elections, which I won't go there. And of course, the formation of many new organizations, both governmental and non-governmental, with respect to artificial intelligence. So here are some of the primary advances in the last year, year and a half. It's particularly been in, I'm going to go through these quickly and we'll come back to some of these in detail. These first two, the progression of machine ability to recognize, identify, and now generate images, and of course videos are simply a series of images. And then secondly, with language and audio or sound in general, the ability to recognize voice, do natural language processing, but now also to generate that language. Of course, machine learning has been greatly advancing in the last year, using one of the techniques called GANs, generative adversarial networks. Big gains in the fields of medicine here, just a few examples. And then, of course, robotics and industrial automation continues to increase. And this impacts Ireland in particular, by the way, because of Ireland's actually heavy use of robots here in manufacturing. Some other recent breakthroughs that I'll talk about in just a minute. I wanted to point out, though, that all of these breakthroughs are fundamentally one big breakthrough. And that big breakthrough is what's called deep neural networks, fundamentally. That's the underlying technology improvement that is impacting what's going on. Now, just a simple chart here on what is a neural network. For those of you, as Bob mentioned earlier, that kind of glaze over, you know, when you see technology. This is a very simple concept. A neural network is made up of little processing nodes. Each of these circles is some type of computer processing software. Let's look at it that way, and they're connected, so they communicate information to each other. The inputs will detect some unique characteristic of the data. So, for example, an image, they may detect where there are edges, a change in color, a change in brightness, bright spots, dark spots, etc. The hidden layers, or the middle nodes, each have their own algorithm or processing function that gather the information from the input nodes. Real neural networks, or a deep network, will have many, many layers, at least 5 of these hidden nodes here. And then there are output nodes, which represent some kind of decision or action. And now obviously you can take a system like this and chain them together, so the outputs of one system then become the inputs to a new one, and so forth. And this is exactly what's being done. So as you give input data and tell the machine, here's what the output should be, you go through a training phase, and the machine adjusts using optimization and mathematical techniques the various parameters in the hidden layers, so that then after the training, the machine can then recognize an image, or it can recognize audio and sounds. And this is fundamentally the deep neural network technique that everything that you see going on with AI today is now being based on. Now, this is an important change because deep neural networks are the first commercially viable capability that has come out of AI research. In the past, the fact that you could beat someone at chess or play the game of Go or something, oh, it's great, but you couldn't go sell that. But the deep neural networks are very commercially viable. Be aware, however, that this deep neural network, despite many claims, this is not a change or a great increase in the ability of general AI, meaning the thinking aspect of the machine. Instead, this new AI is fundamentally based on pattern recognition and the mapping of inputs to outputs. It's a large mapping system. You can think of it like that. There's not any thinking going on with this type of AI. But nonetheless, the use of this AI technique, the deep neural networks leading to machine learning or automated learning on the part of the machines, are powerful and they have widespread applications. Here are some of the top uses according to new gen apps. Chatbots, of course, a lot in e-commerce, and we're going to come back to this in some details. Workplace communication, HR, healthcare, cybersecurity. Bob, thank you very much. I'll have a little more on that in just a minute to amplify what Bob has presented. Logistics, sports betting. It's very interesting, isn't it? Same thing as stock markets almost, or at least how AI is being used. Manufacturing, retail, and casinos, resorts, hotels. Anywhere there's odds on something, and that would include stock trends, bonds, FX market, and so forth, you'll see the AI being used now aggressively. Some more areas include all these virtual assistants, personalized health monitoring. Lots being used in video games, and this has helped to drive some of the technology. Self-driving cars, which you're familiar with, what a lot of the news in that area. Fraud detection, right, being used by banks and many people in the marketing and e-commerce world. Of course, all sorts of banking applications, and then robotics and social media, and I want to look at those in particular. So first, cybersecurity. Bob mentioned the importance of this area, and AI has gotten into this area in a big way because it is complex. So these are some of the things now that AI is being actively used to do in terms of supporting cybersecurity. Now, one of the interesting things, DARPA did a contest a few years ago, and just within a day, people developed reasoning systems that could identify flaws in software, formulate patches, and then deploy those patches in real time. And this was 4 years ago. We had this capability, 2016. Additionally, machine learning is being applied to network monitoring tools. And so this probably impacts a lot of what Dermot said earlier with respect to the internet service providers being able to respond. Now AI is being used to not only do traffic analysis, but also to detect more phishing and anomalies in communication patterns. Lots of companies are in this cybersecurity space, and I won't spend any time talking about them, but many names that you'll recognize and many that are new to you as well. And these are some of the products that you'll see in the cybersecurity market. So, robotics. This was an interesting little statistic. There are over 1 million robots now sorting rubbish, going through the trash and doing waste management. So this is a big increase over the past 10 years. Also manufacturing with automobiles, according to Hyundai data, 80% of car production is now being done by robots. So that's a big area. In social media, some specific things. I'm going to look at 4 companies here in just the next few moments. First, let's talk about Facebook. Facebook is heavily invested in this, including they do a lot of work there. They have a headquarters here in Dublin. And so they're using AI to match their content to your interests. So not only are they using it to analyze the user's interests, but they're also using it to match other content. Of course, face recognition in photos, we almost consider this, you know, common now. You expect it, don't you? But this is an AI technique. Recommending tag options and identifying all kind of visuals for marketing purposes. Twitter does very similar things, facial recognition, but they'll also pick faces out of a larger photograph. And of course, that's being used in the surveillance industry in the same way to find particular individuals in surveillance feeds. Also, it's being used to suggest, you know, to control some of the suggested replies, or when you're typing, you know, it gives you sample words that you might use next, predictive type of texting. So AI is being used for that. Pinterest uses it, of course, to track not only what you're interested in, but more importantly, they've automated the ability to take images of products and determine what the product characteristics are that people would be interested in. And this has been automated a lot. So now the human doesn't have to say, okay, this is a piece of clothing and it would be of most interest to men or women and so forth. This is now able to be done in an automatic way, and it speeds up the marketing and the precise promotion of products. Pinterest points out that 80% of Pinterest users end up making a purchase from content or things that have been suggested using the AI capabilities. And then LinkedIn, they rely a great deal on machine learning. A little quote there at the bottom by one of the LinkedIn officers is that everything you see on LinkedIn is powered by AI. So including fake, you know, trying to figure out which accounts are fake. So these are some of the new techniques that are being used. And in summary, social media platforms are heavily invested in machine learning AI to track trends, to track user behavior, our interests, and to block abusive content. Something to be aware of, or what's called deep fakes. I just have one slide on this, but I want you to be aware of this. And it's worth Googling a little bit about some of these specific examples. The one showing here is Vladimir Putin. On the left is an actual photograph of Vladimir Putin. On the right is a computer-generated face of Vladimir Putin based upon composites of images and also descriptions of the man, and they're almost indistinguishable. This is based on what's called the Viola-Jones object detection framework. That's fancy terms there, I understand, but bottom line is that fundamentally we can recreate your face and put it on someone else's body in a video. This is used by the movie industry, of course, but it's also used by people who have less than honorable intentions, or can be used that way. Also, we can record your voice saying a few short words and then recreate your voice and type in anything on the computer, and the computer will say what we typed in using your voice. And it's indistinguishable from you actually saying that. Chatbots or dialogue bots, the biggest one right now was by OpenAI, called GPT-3, stands for Generative Pre-trained Transformers. So look at the computer AI use of language processing as not just a translator, but a transformer. It transforms, for example, English. It can transform that into computer code. So you can describe computer code that you want the machine to write in English, and it'll write that computer code for you. It can also generate faces from a description. It can give you an automatic summary of an article. So instead of reading the article, the heck with Cliff Notes now, the computer will tell you, here's basically what this article is about. And then the accuracy of this type of automatic capability is improving each month. Microsoft originally made a big investment in OpenAI to be their exclusive cloud provider. The OpenAI was open software, making GPT-3. Elon Musk was someone who was a big investor big money in this, and just this September here, 2 months ago, Microsoft acquired an exclusive license for this, and not everyone in the AI world is happy about that, and we'll leave that right there. AI in Ireland, I just have a little bit on this. There's so much we could talk about. There are lots of companies involved in AI. Our conference here in March last year highlighted a number of these companies, and they are still doing great. It's impressive. But the DBEI now has an action to develop a national strategy based on the theme of AI is here for good. The play on words there is deliberate, of course. Ireland, out of the EU nations, has the highest ratio of AI talent within the EU, that is, compared to the population. But Ireland, at the same time, also has the lowest percentage of government investment in AI. Now, nonetheless, there's still significant investment in AI. A top team for standards has also been established by the NSAI. There's a lot of research going on. Science Foundation Ireland is funding a great deal of this, and I won't get into these details, but I have this here for you to look at off to the side. It's important to see that these are some of the key organizations and universities that are involved. Then we've got the research that they're funding is in these major areas listed over here at the bottom right: environment, smart cities, transport, agriculture, and health. Also, there's a number of training programs available. These are a few that I've listed, and there are now 5. And if I'm wrong on this, by the way, this was the snapshot I was able to get. 5 master's level programs in Ireland at the institutions listed. There may be more than this. Lastly, the impact on engineering. Engineering is already being impacted, and this is going to continue by the new AI techniques. The first is, not only is it being used in production, robotics, manufacturing tasks, and so forth, but now it's impacting design tasks, simulations, enhancing computer simulations, and doing machine learning to improve tasks over time with little or no human intervention. Now, here's an analogy to consider for those of you in the engineering community. Remember how computer-aided design started many years ago, and at first it was something that you could use. It was supplemental. It was, it was just started out really just as two-dimensional, but then it went to three-dimensional, and then it started including fourth dimension of time. So now CAD modeling is commonly used, both for FEA and computational fluid dynamic applications. But in additionally, these tools are now a fundamental part of an engineer's daily activity in the real world. So the integration of AI into engineering is going to follow this same kind of path. It'll be something that some companies are using, and it'll be niche, but then it's going to expand rapidly. For example, generative design. Here's a picture, for example, at the bottom of Autodesk's tool for generative design. Is you can describe or give the constraints of a structure that you need to make a some type of robot, or the frame of a car, or anything mechanical, for example. And the AI now is able to design that item for you and create the CNC instructions to get it fabricated or 3D printed. You're going to see more impacts, and here are 3 major ways that AI is already begun and will continue to impact the engineering profession. First is in the evolution of jobs. In addition to using AI tools in the job, new areas of expertise are already needed, and we see the universities and the training institutions trying to react to this already. And that reaction and the evolution of jobs and the types of expertise needed in data science is going to continue. Secondly is in the improvement of capabilities with these AI tools and the ability to analyze large amounts of data in a concise way. It's going to improve engineering decisions and engineering design activities. And then lastly, it'll assist with the flow and the process, taking a lot of previously tedious tasks that engineers had to perform and automating them, just like finite element analysis, has basically automated the analysis of structures a great deal, and it's not laborious with the slide rule for those of us who remember those. Now, this type of automation is going to use AI tools as well. So in closing, the impact on engineering is going to be that this new Industry 4.0, which is the rise of these AI tools, the interconnectedness, Internet of Things, and so forth, is giving rise to what's called the rise of advanced engineering. So AI is going to be the next engineering platform, and a great many experts are affirming this. But engineering innovation is going to be able to direct a lot of what goes on with the use of AI in engineering. And that's where I'll stop for today and open for any questions that you may have. And I'll pass it back to John or Sinead. Thank you.
Glenn, thank you very much. That was absolutely inspiring. I could listen to you all day, as I could listen to Bob and Diarmuid as well. So now we're just going to open up for Q&A. So if everybody just wishes to put their questions in. But Maurice, I believe you have a question. Am I right?
Well, happy to get the ball rolling. Yeah, listen, thanks guys, the three speakers. Fabulous talks, all of them. We picked three very eloquent speakers and three very diverse topics, all related to the Semple theme. This may be unfair now, it may not be any one of your areas of expertise, but just to ask about cyber attacks in the process engineering area. So I remember being at a conference some time ago, actually the same conference I referred to in this presidential address. I don't get out very much. But anyway, they were saying that where you have like big equipment, for example, a big machine rolling out polymers or steel sheet or something, if that can be compromised and a threat can come in to stop that machine, it costs hundreds of thousands or millions maybe to restart it. You lose all the work in progress. So it's a huge leverage, and that there may be a reluctance on behalf of the big manufacturing companies involved to admit that they're under such attack. That was one. The second one they mentioned was that in terms of military engagements or state security, the example mentioned was the Ukraine and Crimea 5 or 6 years ago, that the power system in the country was infiltrated by those who shall not be named, and that I'm not sure, did they cut off the power at a critical time, which interfered with the ability of the army to mobilize, or did they threaten to do so? But even at that level, I mean, Bob talked about the corporate governance level and board of directors, but and the role engineering could play there, but even down to the dirty level of just a piece of big process equipment, this is a real issue. Would anybody like to comment on that?
Yeah, I wouldn't mind commenting on that. Actually, we're looking at that at the moment, actually, in Carlow. So I suppose you could say this attacks on processes in manufacturing can probably be, you can probably bring its roots back to the Stuxnet virus and the attack on the Iranian centrifuge nuclear power system. Where a Siemens S7 PLC was pretty much attacked to change the frequency of the centrifuge, right? So I suppose that's when it came into the kind of public consciousness, I suppose, that the manufacturing, you know, this kind of boring manufacturing stuff that happens in the background was now, you know, just as much a target of attack as, you know, this big fantastic database in the bank. So, and it also demonstrated that, you know, these machines were not, you know, Windows computers or Linux or Unix computers. These were machines that are manufactured by, you know, Siemens, Hitachi, Aaron Bradley, whatever. And they probably presented different attack vectors than the Windows and Linux and Unix systems that were, I suppose, starting to deal with the problem and have been dealing with the problem by increasing their levels of security. And certainly attacking such a process, I mean, the attack on the Iranian example, basically they changed the frequency of the centrifuge, but presented back to the SCADA system the correct at correct speeds so that the operators didn't realize there was a problem. And those ones you mentioned in Ukraine, there's actually quite a few of those. There was also a nuclear power plant in the US. There's been a number of, another one in India. So there's been a number of very, very high profile kind of nuclear power plants that have been targeted. But of course, that also means that, you know, the manufacturing plant doing, you know, COVID-19 vaccines, just to bring COVID-19 into the story. I mean, you upset the process even slightly, and you know, the vaccine may not be effective or would have to be scrapped. And you know, I've seen and I've talked to people in, say, in the pharmaceutical industry where their run off at night produces physically a very small amount of say tablets, but the actual cost or the, you know, that or the value of those at the end of the night is actually very significant, and any small disturbance in that could impact it. And that may be just time, you know, it might be a latency thing, you know, delaying something, or, you know, because in the manufacturing system we can't afford any latency. So yes, the manufacturing industry has tended to try to ring fence these as well and say, well, actually that's not part of our penetration test. We're going to leave that out. You can penetrate, test our enterprise network, but we're going to leave the manufacturing zone because that's isolated. We don't actually have that connected. But more and more that's changing.
Maurice, can I come in on that, please, if I may, because I endorse everything that Diarmuid has said. I'd like to broaden it out even more, though, because not only have we those SCADA type systems and PLCs and so on to look after, but we have the much broader issue now of the Internet of Things, where increasingly, even in the consumer space, we're introducing devices into our homes and we're popping them onto the network. And the problem with so many of these systems, whether it's the PLCs or the SCADA systems or IoTs, many of them were never designed with security objectives in mind at the outset. And that's a real problem. So when you look at the authentication process, when you look at the basic principles of security, very often they're not built in. And in some of the big cyber attacks that we've talked about, it has been a relative backdoor that has created the opportunity. So in the case of the NotPetya in Maersk, that was because somebody installed a very simple software as a service, you know, $10 a month, whatever, installed it on their computer. That became the backdoor and absolutely wiped out Maersk internationally. It destroyed the domain controllers on every national jurisdiction network, to the point where Maersk was completely blind. It had no vision of anything. It couldn't even make a telephone call because all the calls were voice over IP. So I think there's a big issue here about how do we shift the focus to make sure that security is built in from the start, that those principles are in there, that we adopt a position of trusting no device unless it's verified and validated. And how do we make sure, in addition, that resilience is part of the initial design, not an afterthought? I think those are important questions for us on this call.
Bob, I have a question here from Audrey Barrett, and it's, can Bob suggest any resources to help educate management and board members on cyber resilience? Absolutely.
So what we thought about in relation to this exercise, Audrey, was how do we demystify and take the alphabet soup out of a lot of this stuff? When people start talking about DDoS attacks and talk about ISO standards and all the rest of it, very often the eyes will glaze over. So in the cyber resilience site, we've provided, if you like, a springboard where we provide, in as plain English as we can, the key issues that directors would be concerned about, what they need to know. So we catalog the different types of attack, from ransomware to data theft, to data destruction, to financial fraud and so on, but in very plain English. And then we provide a list of links to say, and here's where you can get more stuff when you need it. So hopefully that's a start. Actually, when you start going digging, I hadn't realized this myself until I started this work. When you go digging, there is an amazing array of stuff out there. The question is, there isn't an easy way of accessing it. And hopefully through the ICS site, we'll provide some of that.
Okay, I have another question here, and it's, I've recently encountered a number of vendors proposing decision support solutions for complex systems problems. However, proposals appear to focus upon the actual decision support aspects and not the security element. Would the panelists care to comment upon the vulnerability of these systems to attack, or is this an area that still requires further work?
Well, I suspect this is Glen's territory more than anything else, because there's been a lot on transparency, accountability, and redress for AI systems particularly. But even on the decision support using native electronic collaboration tools, it comes back to really good design and deciding, you know, have we got the right approach to this? Are we getting the right people involved? Are the right people actually making the decisions on this when they're voting up and so on? But I'm sure, Glen, you have a lot more to add in terms of the impenetrability sometimes of the black box of AI.
Well, I'm glad you think that I know a lot about that. I know some about that actually. The thing that has become apparent to me just in some of the preparations for this talk related to cybersecurity is that, as you've said, Bob, this is actually a way bigger problem than even a lot of us tech people have realized. And as a result, that is why you may have seen on one of my slides, there are so many companies now who are getting into providing basically cybersecurity evaluations, assessments, and so forth as a service. And I mean, you're more of an expert in this area than I am, but at the same time, I would probably suggest that that may be where many companies may have to go. Rather, you know, it's the age-old problem of how do you use AI in general. For example, do you hire a bunch of PhDs or you know, tech people and data scientists? Not well, yeah, you can, but most of us are going to have to go to some service provider initially. And the slide that I had there that listed many of them is certainly not exhaustive. And you can Google this and instantly get big lists of company who are in this space. But I would like to propose that this is likely so big a problem that is exactly why AI is a good tool to solve it, because it can look at way more things than we humans can. It can begin to see these vulnerabilities at the SCADA systems, the IoT devices, you know, and you know, that doesn't mean that the software would provide the solution, but at least companies that we would work with could assist us in knowing what the risks are as we move forward.
I mean, if I put on my business hat for a moment, Glen, you know, as a chartered accountant, chartered director, the question which occurs to me is, what is our core competency as an organization? And can we distinguish between the commodity aspects of AI, where you use machine vision or machine learning, whatever, to perform a particular task in a commodity-like way, where it's relatively predictable and so on and so forth, as opposed to, gosh, we can actually get a leg up on the competition by having a core competency in an aspect of AI, which brings a completely different perspective. Like
Precisely.
When Google introduced, for example, AI into just the management of their data centers, they were able to reduce their electricity consumption by, I think, 40%.
40%, that's right.
Which is a staggering saving. And that gives you a cost competition edge, which then other people can't match if they don't have the same competency. So it's a very interesting question for people to dwell on. What's core versus what's commodity?
I'm actually glad you mentioned that, in that this is why now these AI tools, whether you're one of those people out there who likes AI or you hate AI because you see so much about it, and it is hugely overhyped, of course, in the media. You know, forgive us, but this happens. But at the same time, the companies where marketing and in getting competitive advantage is critical to their survival, they are all using AI tools. If you're in finance or any type of, you know, money business, if you are in retail or selling things, is certainly in a big way, and on the internet, if you're not using AI tools, you're going to be out of business likely. This is unfortunately where we are now, is that these tools give the users of these tools such an advantage, like you mentioned, a 40% savings on the energy cost for a data center, which is the largest ongoing cost of the data center. That's a huge competitive advantage. And so applying this same concept now to engineering design work, applying it to cybersecurity, if we don't start to use these AI tools, we're going to find ourselves, you know, eating the dust of the others who are ahead of us.
Okay, I have a question for Diarmuid from a viewer from Ronan O'Brien, and he's asking, Diarmuid, in your opinion or from factual evidence, what do you attribute to the significant rise in INEX traffic when lockdown started? Increased video conferencing, which replaced face-to-face, or working from home? It would be easy to say that it's VPN traffic moving. What would usually be LAN? Sorry, I'm getting muddled here. Sorry, it would be easy to say that it's VPN traffic moving what would usually be LAN traffic to the internet or something else. And that's part one of the question.
Yeah, so I mean, to be honest, I think it's habits. People's habits is the main one. So people have suddenly rediscovered RTE news, right? Where people that before weren't watching the news, now they're watching the news. They've rediscovered that family, and they're doing more stuff socially at home as well. So there's more online entertainment. You have families that are distributed outside these 5-kilometer bubbles that we're forced into. So now they want to talk to their grandparents or talk to their children or whatever, and they're doing that through social media. So all that is driving content, traffic up. But I'll give you interest. I was the operations officer for the Uganda Internet Exchange Point for a number of years. And one of the interesting things that happened there was the traffic levels dropped as soon as COVID-19 hit in March, which was completely the opposite of what happened everywhere else. So that kind of intrigued me. So I did investigate why did that happen. And it probably answers the question in a kind of a roundabout way. What happened in Uganda was people were working in Kampala, the main city, a bit like Dublin. It's kind of too big and too many people there. But everyone, if you want to work, you have to go to Kampala. So they're working in Kampala and they're connected to the networks in Kampala, generally through work. Suddenly the COVID-19 happened and everyone left Kampala and returned to their villages and towns around the country. What they did then was, there is no broadband infrastructure in rural Uganda except for mobile. So they all moved over onto the mobile networks, MTN and Aircell, etc. And all of those mobile networks are South African based. So they tend to use IXPs in South Africa rather than Uganda. So all of the traffic switched from going through the IXP in Kampala to the IXPs in the various data centers in Johannesburg and Durban, etc. So it kind of answers it. The people's habit changed. They moved, first of all. So they've moved from centrally being in Dublin and all the traffic is around Dublin or the other districts in Cork, Galway and Limerick. But now they're suddenly gone back to Tipperary and to Leitrim and all these other more rural counties. So that completely changes the traffic pattern because now you're pushing people onto consumer networks rather than kind of the large networks designed for corporations. And I mean, those networks are also including consumer around Dublin, it's all part of one network. But when you move out the country, you're now dealing with ISPs who are more interested in the consumer rather than the businesses because they're more volume. So I suppose that pattern of movement, that's one. And the second one is the kind of things we're looking at. So we've rediscovered our news feeds because we want to find out what's the number today, 250 or whatever, and the north is on 600 or whatever those numbers are, because we're interested. But also it's not just about work, it's also about social, it's about educational. So, I have students in my classes that are literally across the world coming into my classes at times, or they're certainly around the country because they only come up, for 2 days every fortnight or whatever. So that has changed. So that's redistributed. What would have been handled in a classroom in IT Carlow is now handled probably in 10 counties around the country. And, it's the same for the secondary schools. I mean, the kids are now interacting more online as well. And I think as we go forward, it will probably change the way we do things long term. So, okay, we all get the vaccine in January or February and it's all gone and we can go back to normal. But I don't think we will be going back to normal because I don't think we could have 63 people participating in this conference today if we were doing it in a pre-COVID model where we all went to Clive Road. So I think you're going to have that kind of change in the way media is presented and the way we communicate won't go back to the normal, but there will be some things obviously will go back to normal. But I think that's it. People's habits have changed, what they're viewing has changed, and where they are has changed.
And I think actually that probably answered the second part of the question that was posed, was what changes do you predict for the future traffic patterns?
Yeah, well, I mean, it does really. I mean, the future traffic patterns will probably come back a little bit back from where they are now initially, but I would see them going back up to 500 gigabits. There's always an increase in the traffic patterns on the exchange anyway, but it's just the level of increase we've had due to COVID-19. So I could predict that, yeah, there'll be some clawback as people go back to work eventually, but it will be small, and it will very quickly go back up to 500 gigabits per second and continue well beyond it. So you could probably look at traffic patterns going through the exchange of maybe, you know, a couple of terabytes in 3-4 years time, you know. So those traffic levels are just rising all the time. But definitely I think you're going to find people who have been happy working at home in, you know, South Kildare saying, well, I don't want to go to Dublin every day anymore. I'm happy enough in South Kildare 3 days a week at least. I'll put up with the train twice a week instead of doing it 5 days a week. And there'll be a pressure on businesses to allow people to do some of that work at home that before they wanted them in on Monday to Friday. So I think that in itself means that we won't go back to the way it was in terms of society, and therefore the internet and the exchange is going to have to respond to that as well.
Okay, thank you. Bob, I have a question here for you. And it's, some companies are undergoing compliance standards for cyber resilience this year as set out by the EU. What is your advice for these companies as they set out to comply with cybersecurity standards?
Well, we could probably have a session just on that question alone, I suspect. So this is about the rule set that we have to comply with. And I typically identify 4 key elements to that. There's legislative, regulatory, contractual, and policy. The legislative is that we have our own governing legislation, and we have particular pieces of legislation. For example, implementation of a number of the EU directives. Some companies will be affected by the NIS directive or by the Payment Services Directive. We're all affected by GDPR and so on. So there's quite a complex set of legislative requirements, number one. Secondly, there are, as an adjunct to that, important reporting requirements. So it is now a legal obligation to report certain types of cyber attack. And if you don't, you're in trouble as an individual company and as an individual board member, and there are criminal sanctions for that. The regulators are getting over this like a rash and imposing a lot more. And the central bank earlier this year did a thematic inspection of asset management firms, and they criticized the industry hugely for non-compliance. And then contractually and policy issues, won't go into that, but to get to that, the answer of this is there are a bunch of different standards. Typically, people will look to the ISO standards in 31000 or 27001 more generally, and there's some more specific ones besides. And then the NIST standards from the US, which provide really, really detailed guidance for people. In the first instance, I try and get the compliance set clear, what's the rules. And then secondly, I'd see what are the best standards that we can apply in the circumstances. Look for the certification, look for the gap identification, remedial, and eventually then you'll be able to put your hand up and say, no, we've actually dealt with that. You may even get external certification, which is increasingly common. And what we're seeing now in third-party contracts is that before I engage with you, I need you to have an independent test that demonstrates compliance with information security management as a standard or whatever the particular standard is. So we're going to be spending a whole lot more time in this space. I'm absolutely confident.
If I could pop in there, maybe with a question to Glen, just on artificial intelligence. Been following with interest some of the pollsters and the anticipation of the US election results for the president. And
yes,
you know, having got it so wrong 4 years ago, I was expecting science to be applied and to be kind of plus or minus 0.01% this time around, but that didn't happen. It just made me think, for artificial intelligence to learn, does it need to be applied to a process that's kind of happening all the time so that you've got this continuous learning? What about, is something like an election prediction difficult for artificial intelligence?
Well, that's a good question, and certainly we should be careful to fall down and worship at the idol of science, because it is not as reliable as often it is held up to be, because it's promoted by we people, human beings, still operate and control these things. But your question about a repetitive process is very good. The key for training AI systems is not necessarily repetitive data, but it's something that has a pattern. So in the case of elections, you know, whether it was for Brexit, which was one of the activities that was alleged to have been exploited, the US presidential election or any other. If there are previous elections, the election system has a pattern in that you've got precincts which go into counties, which go into states, which go into the national level, and these all are interconnected in some way, and there's a process that can be analyzed. That is what AI is fundamentally doing. The deep neural network technique is finding structure. It's finding patterns in things. So previous examples can be used. You don't have to have something that's constantly recurring today, although you may certainly use that as it's done in manufacturing process control, where you have a continuous stream of data and the AI can continuously analyze that. But anything that's structured is very much suitable, because fundamentally the deep neural network technique of AI, which is now almost synonymous with AI, although it's not in reality, but this new technique is fundamentally pattern based. Anything that has a pattern. So it could be elections, how they're done, what's occurred in the past in 2016 or the 4 years prior to that, and so forth. But also images and videos and so forth. All these things have patterns and structure. Almost everything that we do as engineers has pattern and structure. So AI is going to be applied, or can be applied, to all of these things, and I hope that addresses what you were asking.
Okay, listen, thank you everybody. I'm just conscious of time, and we did say we'd try and finish by 12:30. Just before I hand back to Maurice and Mary, I just want to bring a couple of things, a couple of training courses to your attention. Tomorrow, the Irish Computer Society will hold a data protection event, starting at 11 on the topic of data transfer and SCREMs. Further details on the Irish Computer Society website. And on December 3rd, the Engineers Ireland training team will run a seminar titled Introduction to the Internet of Things in Engineering, which I think we looked at here today, and further details on the Engineers Ireland website. So, and I'd like to thank everybody for submitting questions during the Q&A. So I'll hand you back now to Mary Cleary and Maurice Buckley to formally close the webinar. Thank you very much.
Shall I step in first, Mary? Well, just to thank you and everybody from ICS. I see Bob there with the nice ICS logo over his screen for this event. I certainly personally found it very interesting. As I said already, great variety amongst the three speakers, and really interesting, and somebody said along the way, challenging as well, the questions asked. So it's great, and it's just super from an Engineers Ireland point of view to have this joint event in itself and to have the link again. Maybe just to the audience to thank you for the questions, but if this event has triggered some thoughts as to future joint activities we might host together, I mean, please do write into either the ICS or Engineers Ireland and get us thinking. So thank you everybody for attending, and Mary, I'll leave you the last word.
Oh, thank you very much. Thank you, Maurice. And I echo everything that Maurice said in thanking the speakers and the questioners and the audience for being here to listen. It always strikes me when I listen to presentations like these today, how relevant really to everyday life the lofty work and research and innovation of engineers and IT professionals are. And outside of this particular audience, there are lots of ordinary citizens who are really impacted by connectivity and myths about cyber attacks and the dangers and deep neural networks, even though they mightn't quite know what they are, but they impact on them. And it's really important, I think, that we bring a message to them of how professionals take great care, and they bring ethical considerations, and they think about security by design as they're working through all of these innovations. So our citizens need to be cautioned, but they also need to be assured that they're in good hands, that the professionals, the engineers and IT professionals are really looking after their good. So I hope we've more of these events. Really fantastic morning, and again, thank you all very much indeed.